If I want to convert any binary number to decimal, then multiplication process only we have to follow, but while multiplying, multiply by 2. If it is binary number, multiply by 2. If it is octal number, multiply by 8. If it is hexadecimal number, multiply by 16. If I want, I can use binary number, or I can use octal number, or hexadecimal number. Whichever number you want, you can use, but the result will be same. Welcome back to One and All. Myself, Vasanta, lecturer in Computer Science, Vidhyaashram, Pre-University College, Temple of Excellence, Mysore. Today, we have to start with the fourth session of Data Representation chapter. In the previous session, already you have come to know decimal fraction to binary, how to convert a decimal number, especially fractional numbers to binary format, decimal fractions to octal format, as well as decimal fractions to hexadecimal format. On today's class, you will come to know regarding binary to decimal, how to convert a given binary number to decimal, octal number to decimal, hexadecimal number to decimal, as well as few problems on this conversion, especially from binary to octal or octal to hexadecimal or from hexadecimal to binary, like that. All type of conversion problems today you will come to know. Now consider in the question, if you get convert the given binary number to decimal number, then first thing you have to observe that which type of number it is, first you have to identify. For example, in the question, if you get decimal number to binary, then you have to follow with division process. You want to convert it to binary, that's why divided by 2. In the question, if you get decimal to octal number, then division process, but divided by 8, because we want to convert it to octal. In the same way, decimal numbers to hexadecimal, that is hexadecimal, then division process only, but divided by 16 here. Then it means that from decimal to other bases, division process. For example, in the question, if you get a binary to decimal, then multiplication process you have to go, but while multiplying, you have to multiply by 2. Don't multiply by 10 here. Then if you want to convert octal to decimal, then once again multiplication process, but multiply by 8. In the same way, hexadecimal number to decimal, then also multiply by 16. See, decimal to other bases, division process. From other base to decimal, multiplication process. Consider you have the binary number 1101 to decimal. Then binary to decimal, then multiplication process you have to follow. Each digit, first digit into 2, multiply by 2, then plus. Now see the second digit 1, 1 into 2, then plus. Once again we have 0, 0 into 2, plus. Here 1, last 1 into 2. First like this you have to write, because multiplication process binary to decimal, multiply by 2. Here we have the digits 1101, then each digit we have multiplied by 2. But from right side, increase the power value. First write down 0, then 1, 2, 3. 0, 1, 2, 3. Then later on perform the action, that is 1 into 3, how much? 1 into 2 to the power of 3, that is 8 we are going to get, plus 2 square 4 into 1, that is 4, plus 0, here 0 into any number is 0 only, that's why here we have written 0. Then 2 to the power of 0, any number if the power is 0, then that value is 1 represents, then into 1. Then you have to add all the values, then 4 plus 8 plus 4, 12, 12 plus 1, 13. In the base, we have to write 10. Now, is it clear? It means that if I want to convert any binary number to decimal, multiplication process, but while multiplying by 2, you have to multiply. If it is octal to decimal, multiplication process only, but 8. In the same way, whereas in octal, it increases the power by 0, 1, 2, 3, but multiply by 8. If it is hexadecimal number to decimal, then multiplication process only, but multiply by 16. Now we will see some more problem. Consider this is a binary number we want to converting into decimal format. Each digit we will multiply by 2. See, the first digit multiply by 2, then second digit multiply by 2, third digit multiply by 2, multiply by 2, multiply by 2, multiply by 2, multiply by 2. But here, if you observe this, here first 3 digits, 1, 2, 3, 4 digits, then afterwards we have point here. Then here on this point, power will be 0, 1, 2, 3. For the 2, we use right, the power is 2. See here, 0, 1, 2, 3. Here also 0, 1, 2, 3. But after point, we have 1 into 2 to the power of minus 1 you have to write. Here 0, from this point to left side, we have to increase the power by 0, 1, 2, 3, 4. From here, we have to increase the power. If you want to move right side, then once again, in the minus sign, you have to increase. Then 1 into 2 to the power of minus 1 you have to take. Then 1 into 2 to the power of minus 2. Then 1 into 2 to the power of minus 3 we have to write. That means after point, if you are moving left side, then positive sign. If you are moving right side, then negative sign you have to write. Then here, perform the process. Here 8, 4, 2, 1, because 2 to the power of 0 is 1. Then here we have the point as usual. Then 1 into 2 to the power of minus 1 here we have. That is 2 to the power of minus 1 if you have. Then how to solve this? Directly we cannot able to calculate. That's why what we will do, we will convert that into positive format. The power we want to convert into positive format. For that, 1 into 2 to the power of plus 1 we will write. Then that is 1 into 2 to the power of divided by 1, 2 we are going to take. And here 1 divided by 1 into 2 to the power of minus 2 we have. That will write 1 into 1 divided by 4. If you have 2 to the power of minus 2, then how to write that? 1 divided by 2 to the power of 2 to make it as positive. Then that is equals to 1 divided by 4. That's why 2 to the power of minus 2 we are written 1 by 4 plus 1 into 2 to the power of minus 3 we are written as 1 by 8. Then do the calculation. 8 plus 4 plus 2 plus 1. Here 0.5, 1 into 0.25. 1 into 0.125. When you add 150, 0.5, 0.25, 0.125, finally we are going to get 15.875. In the base we are written as 2 because in the base we are written as 10 because we want to convert this binary number to decimal number. Already I told you, if I want to convert any binary number to decimal, then multiplication process only we have to follow, but while multiplying, multiply by 2. Whereas in this program, you have point fractional part. Then if you have fractional part, you have to increase the power by minus 1, minus 2, minus 3 like that. You have to increase the power. Consider we have 117 in the base we are written as 8. It means that it's octal number. How to convert an octal number? Already I told you here, if I want to convert octal number to decimal number, then multiply by 8 here. Then in this case, what you will do? First digit, that is 1 into 8 square plus 1 into 8 to the power of 1, then 7 into 8 to the power of 0. See, first digit 1 into 8, first digit we are written plus 1 into 8 once again, second digit plus the last digit that is 7 into 8. First you have to write like this. Then increase the power of 8, 0, 1, then 2. When you calculate this, 1 into 8 square that is 64 plus 1 into 8 to the power of 1 is 8 only plus 7 into 8 to the power of 0. Any number if the power is 0, then the value is 1 here. Then that is equals to 64 plus 8 plus 7. That is equals to 79. Like this, you have to calculate. You have to convert the given octal number to decimal number. Next, consider we have hexadecimal number digit that is 79.35. It's an hexadecimal number because in the base we have 16 to decimal format. Already I told you here, if I want to convert hexadecimal number to decimal, multiplication process only, but multiply by 16 here. See, here consider the digits 7, 9.35. First digit 7 into 16 plus 9 into 16. Then here we have point. Point that is 3 into 16, 5 into 16. See, after point from left direction 0, 1, 2, 3 like that you have to increase the power. Whereas if it is point after that, that is fractional part, then minus 1, minus 2, like that you have to increase the power. Then 7 into 16 plus 9 into 16 to the power of 0 is 1 plus 1 into 1 divided by 16. Because here we have the negative sign minus 1 to make it as positive, write down the denominator, plus 5 into 1 divided by 256. When you perform the calculation, 112, 9, here 0.1875, then plus 5 into 1 divided by 256, the value is 0.01953. When you add 121.207 in the base 10. It means that if I want to convert any number like binary, octal as well as hexadecimal to decimal, multiplication process only you have to follow. If it is binary number, multiply by 2. If it is octal number, multiply by 8. If it is hexadecimal number, multiply by 16. Now is it clear for all of you? Now consider FEAD, it is an hexadecimal number. How to convert this into decimal, octal as well as hexadecimal? This type of question in the annual exam, they will go to ask for 5 marks. Because from one base to remaining all the bases you have to convert. Whereas FEAD, it is an hexadecimal number. Already you know how to convert an hexadecimal number to decimal, that is multiplication process, but multiply by 60. But whereas here we have to convert from hexadecimal number to decimal as well as octal as well as binary. Then on that case, write down their equivalent number. While writing the number, here FEAD we have. Then what is the value of FEAD? How to identify? Already I told you in hexadecimal number, it starts from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. After 9, you have A, B, C, D, E, F. Whereas A represents 10, B represents 11, 12, 13, 14 and then F represents 15. Whereas on the place of F, substitute 15, that is 15 into 16. Plus on the place of E, E represents 14, that is 14 into 16. Plus 10 represents A, here A 10 into 16. Then D represents 13, 13 into 16. And increase the power 0, 1, 2, 3. Then when we perform the calculation, 15 into 16 cube, we are going to get 61440 plus 14 into 16 square, 3584 plus 10 into 16 to the power of 1, then 160. Then here 13 into 16 to the power of 0. Any number if the power is 0, then the value is 1. 1 into 13 is 13 only. Then when you add, then we are going to get the result 65197 is a decimal number. First part we have completed. Now we have to convert that into octal as well as binary. If I want to convert this into octal number, then once again here we know the procedure. Already I told you regarding decimal to binary, decimal to octal, decimal to hexadecimal. Binary means 2, octal means 8, hexadecimal number means 16. Then how to convert this one? See, take down the decimal value 65197, then divided by 8, because now we want to convert that number into decimal format to octal number. Then divide by that, then 8149, remainder 5, note down the remainder. Then once again when you divide it by 8, 1018, remainder is 5. Then once again divide by 8, 127, remainder is 2. Then once again divide that 127 by 8, then 15, remainder is 7. Then once again divide that 15 by 8, then 8 ones are, remainder is 7. Then note down the value from bottom to upward direction. Therefore 177255 is the octal number and this is the decimal number. Then how to convert this into binary format? There are two methods. If you want, you can take the decimal number to binary or octal number to binary or hexadecimal number to binary also you can convert. Whereas converting here, write down the equivalent binary digits. Equivalent binary digits. For 1, the binary digits are 001. The next 7, 111. Once again 7, 111. For 2, 01. For 5, 101. For 5, 101. That's a binary number. See, if you want, you can use hexadecimal number, decimal number, octal number to write the equivalent binary number. While writing, write down the equivalent 3 bits binary numbers to get their equivalent binary values. Now is it clear? Consider we have one more problem, 123.25. It is a decimal number. How to convert there into binary, octal as well as hexadecimal? Consider here we have 123, then division process, 2 16 ones are, remainder is 1, 30 is a, remainder is 1, 15 is a, remainder is 0, 7 is a, 14, remainder is 1, 3 is a, 6, remainder is 1, then 3 ones are, remainder 1. Write down this in bottom up approach. Then their binary value 1 1 1 1 0 1 1. But for fractional part, take down 0.25. Consider only the fractional part, 0.25 into 2, then the result will be 0.5. Once again, take down only the fractional part, that is 0.5 into 2, then 1.0. Write down this value from top to bottom. Then here, the integer part only to write. Then 0, 1 in the base 2. From this, I can identify the binary value. The first part is clear. Next, how to find octal as well as hexadecimal number. Here we have the binary digits. Then make 3-3-bit separations. Make 3-3-bit separation. Then here we have point. Then from this point I will make 3-bit separation. 1, 1, 0. Then once again 111, 1, 1, 1. Then once again only 1 we have. Then to make 3 bits 00. Here we have point as usual. Then 0, 1. To make 3 bits, write down here one more extra 0 here. Right side you have to write. Here if you want left side, whereas here right side you have to write the extra zeros. Then 001, the binary value is 1. Then 111, 7. 011, that is 3. Point here 010, the value is 2. From this, I can able to find the octal number. Then in the same way, consider you have 7b.4. How to identify that? The same binary value, make 4-bit separation. See, from this side, left direction you have to move, whereas after point, right side you have to move. 4-bit separation. Here, 1101. 1 we have written. Then once again, 111 we have 1, 2, 3. To make 4 bits, here write down one more 0 here. Now after this point, we have 0, 1. To make 4 bits, right side you write 00. Now write down their value 011, that is 7. Here 1011, the value is B. Then point 0100, the value is 4. Then hexadecimal number. Now how to identify their binary value as well as octal value? We'll show some more problem, then you will come to me. For example, in the question, if they given binary number and you have to convert that into remaining bases, that is octal, decimal as well as hexadecimal. Here, if you want to convert, you have to follow some rules and regulations. For example, how to find their binary value for this number or how to find octal number for this binary value. To remember that, we have one procedure. Write down 4 times 0, 4 times 1. 1, 2, 3, 4 times 0. Then write down 4 times 1. 1, 2, 3, 4. Then 4 times 0, 4 times 1. Off of that 2 times 0, 2 times 0, 2 times 1, 2 times 0, 2 times 1. Then next alternative 0, 1, 0, 1, 0, 1, 0, 1. If it is octal number, then here 0, 1, 2, 3, 4, 5, 6, 7. Now from this only make 3-3-bit separations here. 1, 1, 0. Then here 1 we have. To make 3 bits, here we are going to write 0. Now see here 0, 1. What is the value? 3 we are written. Once again 0, 1. The value is 3. Here we are written 3. If we make 3-3-bit separation, then octal number we are getting. Then if I make 4-bit separations, that is for example 4 bits means 1101, 1101, then only 1 we are getting, write down 4 zeros. To make 4 bits, 000, 0001, 1011. How to identify their value now? Here write down on the 3 bits, if you have, on that time 4 times 0, 4 times 1 we used to write. If it is 4 bits, then write down 8 times 0, 8 times 1. 1, 2, 3, 4, 5, 6, 7, 8 times 0. Then write down 8 times 1. 1, 2, 3, 4, 5, 6, 7, 8. Then 4 times 0, 4 times 1, 4 times 0, then 4 times 1. Next, here, 0, 0, 1, 1, 0, 0, 1, 1, 0, 1, 1, 0, 1. Here 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. Now after this 8, 9, on the place of 10, write down A, B, C, D, E, F. Now A represents 10, B represents 11, 12, 13, 14 and then this is 15. See how to identify this? Write down 8 times 0, 8 times 1, then 4 times 0, 4 times 1, 2 times 0, 2 times 1, then alternate is 0, 1, 0, 1. Write down their binary value as well as decimal number, hexadecimal number. If it is octal number, consider only 3 bits. If it is hexadecimal number, consider 4 bits. Now here if you observe 0001, which is a 0001, the value is 1 that we are written. Then 1011, 1011, the value is B. Here we are written B. Then this is the hexadecimal number. Now if I want, I can convert the decimal number by using any of the 3 values. If I want, I can use binary number or I can use octal number or hexadecimal number. Whichever number you want, you can use, but the result will be same. For example, if you consider the hexadecimal number, that is 1 into 16 plus B represents, already I told you, B represents 11, 11 into 16 power 0, 1. 16 plus 11, that is 27. If you want, you can use this hexadecimal number to convert it to decimal number, or if you want, you can use octal number. Octal number, if you want to convert octal number to decimal number, then multiplication process, but multiply by 8. That is first one 3 into 8 plus 3 into 8. Then power 0, 1. Here if you convert this, then 24 plus 3, that is equals to 27. If you want, you can go this method or this method. Otherwise, if you want, you can use binary number also. Each digit multiply by 2. Then increase the power. Here 0, 1, 2, 3, 4. Then also you will get the same result, 27 only. It means that from whichever number to whichever number you want, you can convert. Whereas in this case, by using binary number also you can convert it to decimal, or from octal number to decimal number, or from hexadecimal number to decimal number. Now is it clear? Now we will show you one more problem. Consider this is the octal number 1375. How to convert this into binary as well as hexadecimal as well as decimal. See, directly if you write 3 bits, then we can able to get their equivalent binary number. See, if you observe here, 3 bits here to write. First one we have 1. For 1, what is the value? 001. Here we written 001. Next for 3, what is the value? 011. Here we are written 011. Then next for 7, we are written 111. Here we are written 111. In the same way for 5, what is the binary value here? 101. Then here written 101. Then if you write this, then we are going to get the binary value. Then if you want to write hexadecimal number, take on the same number and make 4-bit separation. See, 1, 0, 1 and one more 1 here we are written. Then here we are written the comma, 4 times 1, comma, 0, 1, 0. Their equivalent number. See here, for 0010, what is the value? Here the value is 2. Here we written 2. 4 times 1, what is the value? 4 times 1, that represents F. We are written F. Then 1101, 1101 represents D. That is a hexadecimal number. This is a binary number. This is a hexadecimal number. Then if you want, you can convert this octal number to decimal number, or binary number to decimal number, or hexadecimal number to decimal number. Whichever number you want, you can perform. If you consider octal number, multiply by 8. If you consider binary number, multiply by 2. If you consider hexadecimal number, multiply by 16. Now, whereas here we have considered the hexadecimal number, that is 2 into 16. F represents 15 into 16, D represents 13 into 16. Increase the power 0, 1, 2, 3 like that. Then here 2 into 16 square is 512, 5 into 16 to the power of 1, 240, 13 into 16 to the power of 0, that represents 1, that is 13. When I add, then we are going to get the result 765. That means here we are used the hexadecimal number. If you want, you can use the octal number also. If it is octal number, then 1 into 8 plus 3 into 8 plus 7 into 8, then 5 into 8. Then increase the power 0, 1, 2, 3. Then calculation 1 into 8 cube is 512. 3 into 8 square is 192. 7 into 8 to the power of 1 is 56. Then 5 into 8 to the power of 0 is 5 only, because this value represents 1. Then when you add, then we are going to get 765. It means that whichever number you want, we can able to convert. And the result, you are going to get the same result. See, here I used hexadecimal number, here I used octal number. If you want, you can find the result by using binary number also. When you finding the binary number, on that time, but multiply by 2. If it is binary number, multiply by 2. If it is octal, multiply by 8. If it is hexadecimal number, multiply by 16. Now is it clear? In the next class, you will come to know regarding the ones complement, subtraction, ones complement, how to perform. What do you mean by complement first of all? Ones complement, twos complement, how to add a number by using ones complement, or how to subtract a number by using ones complement as well as twos complement. The conversion regarding that next class you will come to know. Thank you for all of you.